Welcome back, friends. This is the continuation of our topic of sets of matter. In the previous session, we discussed about the behavior of non-AD solution of positive deviation on distillation, and today we are going to discuss about the behavior of non-AD solution of negative deviation on distillation. Now, if you are with me in the previous session, I hope you understood the session and I can't repeat everything, so today let's go on and we'll touch some of the few differences, what is happening in the non-AD solution of positive deviation and what is happening in the non-AD solution of negative deviation, and what of the few things you need to note or need to remember in understanding about the non-AD solution. So we are saying that non-AD solution of negative deviation, when distilled, tend to give vapor above the surface, which is richer in one component and deficient of the other component, such that the residual solution which remain behind should attain isotropic composition. So in negative deviation, things are somewhat different from positive deviation, because in negative deviation we are saying that the vapor is the residue. The vapor is the one which will be containing the pure component, and the residue will form isotropic mixture. In positive deviation tuliona kwamba distillate ndio inayoform isotropic mixture. Huku inayoform isotropic mixture sio distillate, ni residue. Sio distillate, ni residue. Kwa hiyo kwenye collector huku tutapata pure component, wakati kwenye residue tutapata isotropic mixture. Hii behavior ni tofauti na kule kwenye positive deviation. Hasa ili unielewe, lazima uwe umeangalia kipindi kilichopita cha kuhusu positive deviation, behavior of non-AD solution of positive deviation on distillation. Kwa hiyo sasa ninachokisema ni kwamba the boiling point of the formed isotropic mixture is higher than the boiling point of pure components of the solution. Ndio maana kwenye positive deviation nilisema hivi kwamba solution isotropic mixture inakuwa ni more volatile, yani na boiling point ndogo. Lakini kwenye negative deviation kuna boiling point ambayo ni kubwa, kwa ndio maana isotropic mixture inakuwa left kama nani? Kama residue, kwa sababu zile pure liquids zina boiling point ndogo, so they will evaporate to decrease the concentration of solution so that to reach isotropic point or isotropic composition. So non-AD solution of negative deviation, when distilled, boils in such a way that the residue which remain in the distillation flask or boiling flask attain isotropic composition, and the distillate contain the pure composition. So distillate inakuwa imecontain pure composition na residue inapata nini? Isotropic composition. So pure composition inakuwa kwenye distillate au kwenye collector, wakati kwenye boiling flask au kwenye distillation flask kinachobaki ni isotropic mixture. Hii ni very important for you to remember, because this is different from what is happening in the positive deviation. Hence, in non-AD solution with a negative deviation, the residue must be isotropic mixture, but the pure component is corrected as a distillate. Pure component is corrected as a distillate, and this depends on the composition of the solution. Pure component itakayokuwa collected in the distillate depends on the composition of the solution, and non-AD solution and not on the volatility. Kwa hiyo kama tulivyosema kule kwenye positive deviation kwamba what will be the pure component and what will be the residue will depend on the composition of the solution and not on the volatility. Nadhani kwa positive deviation uliona tukianzia left of the graph na tukianzia right tunapata pure component za aina gani ambazo zilikuwa hazitegemeani na volatility ya zile component, kwamba which one is more volatile than the other, but they were depending in the composition of the solution. Kwa kama composition is greater than the azeotropic composition tuliona residue inakuwa nani, na kama composition is less than the azeotropic composition tuliona residue inakuwa nani. So in this case sio residue tena, kwa sababu residue ni azeotropic mixture. So tutaona distillate atakuwa nani, pure component tunayempata kama distillate atakuwa nani kwenye different conditions ambazo tutakuwa tunazidiscuss. Kwa hiyo tunachokisema ni kwamba the non-ideal solution of negative deviation cannot be separated into pure components due to the formation of azeotropic mixture. So they can't be separated into pure components due to the formation of azeotropic mixture. So let's see about the boiling point composition curve. Boiling point composition curve for non-ideal solution of negative deviation. Boiling point composition curve inakuwa inaonekanaje na explanation zake. Sasa consider kwamba non-ideal solution of negative deviation with the component A and B wana form boiling point ambayo itakuwa ni kubwa kuliko ile ya pure liquids. Kwa graph yetu itakuwa imebend kwenda huko juu, na unaweza kuchora tu hapo tukawa tuna liquid A, temperature of A, liquid B, temperature of B, azeotropic point, azeotropic mixture, then azeotropic composition as usual, azeotropic composition as usual. Now consider a non-ideal solution of negative deviation containing a mixture of nitric acid and water. This is just like an example of non-ideal solution of negative deviation containing nitric acid and water. So nitric acid and water form a mixture in which particles or molecules break away to form vapor with much more difficult than in the pure liquids. So the intermolecular forces of attraction in the mixture of this non-ideal solution, they are higher as compared to the intermolecular forces of attraction in the pure liquids. Kwa hiyo kama intermolecular force of attraction they are strong, manake the azeotropic mixture will boil at a higher temperature as compared to the temperature or the boiling point of the pure liquids. So nachokisema ni kwamba the vapor pressure of the mixture forms a vapor pressure composition curve which is lower than that predicted by Roots law. Kwa hiyo tulisha discuss kwenye vipindi vilivyopita kuhusu vapor pressure composition curve. Tulisha discuss kwa hiyo vapor pressure composition curve ya non-ideal solution na tulishaona inakuaje. Hiyo vapor pressure composition curve. Kwa hiyo tulisema kwamba ile vapor pressure inakuwa na vapor pressure ambayo ni ndogo, na ndio maana itakuwa negative deviation. This means that the mixture of nitric acid and water can have boiling point higher than either of the pure liquids because they need extra heat to break the strong intermolecular forces of attraction in the mixture. Now consider a mixture of nitric acid and water with a boiling point of 120.5 degrees Celsius, ambayo hii ni kubwa kuliko boiling point ya water na boiling point ya nitric acid. When the mixture contains 69% of nitric acid, hiyo ndio itakuwa nini? Azeotropic mixture. So the boiling point of nitric acid is 86 and that of water is 100, ambayo inajulikana. Ukiangalia phase diagram ya hawa itaonekana kama 100 ni ile pale, then 100 ni ile pale, then 120 ni ile pale, 86 ni ile pale, na azeotropic mixture imekuwa formed pale. Sasa hii grafu hizi notes ambazo nilisoma mwenyewe wakati nasoma. Hii graph kama kwa sasa ukinicholea mimi kama nina maki mtihani naweka kosa. Kwa nini? Kwa sababu wewe ukiangalia hapa huku tunaelekea kwenye water, alafu umeweka 68, yani 068 100 iko huku. This is incorrect. 68 might be lying on the right hand side which is near to the nitric. So this graph it is incorrect. In other words, the graph is incorrect. Now the correct graph for hiyo liquid ningeweza kuichora hivi. Correct graph ningeweza kuchora hivi. Kama huku tu tuna water, huku tu tuna water, tu tuna nitric acid. Tuna water, tuna nitric acid. Yaani maana yake hapa ni kwamba ninafundishia notes ambazo nijifunzia mwenyewe, lakini kwenye makosa tunarekebisha kabisa. So water inaweza ikawa labda iko hapa 100, then nitric acid inaweza ikawa iko hapa 86, then 120 labda ambako ni hapa. So 68 lazima ilai huku, that means itakuwa hivi, let's say here is our 68% or 68%, 100%, and then 0%. Somehow hii inayolai kulia near the nitric acid kidogo inaonyesha na ukweli kidogo kuliko ile nyingine kidogo. So hiyo inatakiwa iwe hivyo, na hiyo hapo inatakiwa iwe namna ile pale, inaenda mpaka wapi? Mpaka kwenye water. So from here tutaweka temperature hapo hiyo 120.5, and then hapo tutaweka azeotropic mixture, na toka hapo kutaweka boiling point, na huko tutaweka boiling point. So from there itakuwa kama hivyo. Huko tutaweka water. Vitu vingine kama vilivyo kwenye graph ni correct. Kasoro tu ni kuwa na correct kitu kimoja, kwamba hii graph kitu kilichokosewa ni kwamba hii 68 imelai huku. Wakati huo tunategemea hii 68 ingelai wapi? Ingelai near the right hand side, which is near the side of nitric acid. So that's the only thing which was wrong in this graph. That was wrong. Sasa from this graph again we can have two cases. Remember, in the positive deviation we discussed if we have excess of any liquid, what will happen. So in this case again we can have excess of either water or excess of nitric acid. Lakini in all of the cases ni kwamba if we are starting with excess of nitric acid tuta distillate, and then at the end of the day if we are starting at a solution ambayo ina composition fulani pale, let's say hii composition imezidi 68, so let's say this composition is 70, so we'll distillate, we'll evaporate to condense to evaporate. At the end of the day we'll get pure nitric acid as distillate, pure nitric acid as distillate in the collector. Remember, kwenye hii case residue ni nani? Azeotropic mixture. Huku ni tofauti na kule kwenye positive. Huku residue ni azeotropic mixture. Distillate ndio anakuwa pure component. Lakini tungeanza na solution fulani ambayo kabla iko hapa, hii tunge evaporate, tunge condense, tunge evaporate. At the end of the day tungepata pure water as distillate. Pure water as distillate in the collector. So you see kwamba tuna pure water as distillate na tuna pure nitric acid as distillate kwa kutegemea na composition tuliyoanzia. Kwa hiyo tukianza na composition ya hapa ambayo ni less than 68, composition percentage composition which is less than 68%, that means pure water will be found in the collector as a distillate, and then residue ni azeotropic mixture. Na tukianza na percentage composition which is greater than 68%, manake pure nitric acid will be corrected as the distillate in the collector, and the residues azeotropic mixture. Kwa hiyo tunachokisema ni kwamba case 1, distilling a mixture containing dilute nitric acid, yani less than 68, less than 68 of nitric acid. What will happen? Starting with the dilute solution of nitric acid with composition C1, and it traces through what will happen when the solution is distilled. When the solution containing less than 68 is distilled at C1, the vapor produced is richer in water than the original acid. Kwa hiyo manake vapor yetu itakuwa imeongezeka nani? Water. And on successive distillation and condensation, on successive evaporation and condensation, finally we'll end up with water as the pure component in the distillate. So fractional distillation of nitric acid will enable to collect pure water, will enable you to collect pure water from the top of the fractioning column at the distillate in the collecting flask. Kuna baadhi ya words hapa hata mwenyewe napata shida kusoma kwa sababu somehow nilivyokuwa naandika hapa ilikuwa tu nili uandike notes za mwalimu, lakini sometimes ndio hivyo tunavyosoma, things inakuwa vingi, kwa hiyo tunaandika fast, na huyu mwalimu alikuwa anataka uwe fast kidogo. Kwa hiyo now ndo kidogo tunaona umuhimu kwamba tuliandika kitu tunaweza tukawasaidia watu. So kilichopo hapa ni kwamba tutapata pure water kama nani? Kama distillate kwenye collector, lakini residue yetu tutakuwa ni isotopic mixture. So as the acid lose water, it become more concentrated. Its concentration gradually increase until it reaches 68 of nitric acid. So unachotakiwa kujua hapa ni kwamba property ya huku ni different kutoka kule kwenye positive. Kwenye positive residue ilikuwa pure liquid, lakini ku pure liquid unapata nini kwenye collector? Pure liquid yupi? Ni yule aliyezidi. Kama hapa ikiwa 60 less than 68, maana yake aliyezidi nani? Ni water. At that point the vapor produced has exactly composition as the liquid because the curve meets what is produced in the constant boiling point mixture, which is isotopic mixture. So if you distill dilute nitric acid, what is eventually left in the distillation flask is isotopic mixture, and pure water is collected as distillate in the collecting flask. Therefore, you cannot produce pure nitric acid from dilute acid by distilling its mixture solution. You cannot produce pure nitric acid. This is what happens if we have a solution at concentration C1, we distill it, then after evaporating it, we condense, we get composition C2, then we evaporate again, composition C3, we condense. At the end of the day, we will get pure water as the distillate in the collector, and the residue will be isotopic mixture. But in case 2, tukianza na solution ambayo imezidi nitric acid which is greater than 68, that means if we have a certain concentration there, evaporation, then condensation, evaporation and condensation will end up with the nitric acid in the collector as pure component, and then the distillate, the residue will be isotopic mixture. So residue will be isotopic mixture, and the pure component in the collector would be nitric acid. So in case 2, distilling a solution of nitric acid in the water containing greater than 68% of nitric acid. So distilling a solution with a concentration of nitric acid, with concentrated nitric acid, what will happen? Tukitaka kujua nini kitatokea ni kwamba kama ikiwa imezidi nitric acid, imezidi 68, maana yake nitric acid itatakiwa ipungue. Itakayopungua itaenda wapi? Itaenda kwenye distillate. So tutaipata kwenye distillate kama pure nitric acid. So when the solution of nitric acid containing greater than 68% of nitric acid is distilled at C1, the vapor produced is rich in nitric acid. If you condense and reboil the liquid formed, you will get the vapor richer in more nitric acid. So nitric acid itakuwa inaongezeka. So if you continue doing this all the way up to the fractioning column, pure nitric acid is obtained as a distillate, and the residue is isotopic mixture. So kama imezidi nitric acid, pure nitric acid will be the distillate. Kama imezidi nitric acid, kama imezidi water ndio itapatikana kama nani? Distillate. Isotopic mixture inakuwa nani hapo? Residue. The isotopic mixture is residue. So tunachokisema ni kwamba its concentration or composition drifts down or towards the isotopic composition. Once it reaches that, there can't be any change in the composition because it then reboiled to give the vapor with the same composition as the liquid. So distilling nitric acid, a water mixture containing more than 68% of nitric acid, gives you pure nitric acid from the top of the fractioning column. Pure nitric acid from the top of the fractioning column, and the collector at the distillate in the collecting flask, and azeotropic mixture as the residue. Hiyo azeotropic mixture itapatikana kama residue. So hapo tunakuwa tumemaliza kuhusu behavior of non-ideal solution of negative deviation on distillation. That is how the non-ideal solution of negative deviation tend to behave on distillation. In the next session, we discuss about the differences between ideal and non-ideal solution. Nataka kudiscuss vitu vingine kuhusu some of the few solved examples before we move to other parts of this topic of states of matter. So we'll have many of the solved examples. Moja kati ya kitu ninachoweza kuambia ni kwamba usijump session. Kwa usiwakuta session tunasolve maswali au ukajump. Ukijump you'll be very shallow, kwa sababu you will not be competent in answering the questions. Discussing and understanding the note is one thing, but knowing how to answer the question is another thing. Hata hivyo, I want to start a program in which I will be solving the questions. I will be solving the questions of different exams, a mixture of questions from chemical equilibrium, kinetics, different questions. Hiyo ili kupata uwe una technique mbalimbali za maswali. Because I know most of you have materials, but you fail to answer the questions. So I want just to help you so that you can know how to answer the questions. So thank you everybody, and let me wish you nice studies.